After the CPU has completed its process, it will in many cases need to display the result. The information is passed eventually to the display adapter, ready to be presented on a screen such as a TFT or CRT monitor. The actual screen in the display is basically made from tiny dots. Although not strictly accurate, each of these dots must be traced out in the memory of the computer. So when it's time to display a picture, the information found within the memory is copied to the monitor. Where this memory resides depends upon if a video card or graphic adapter is fitted. In our video tutorials, the graphic adapter is an integrated part of the motherboard which does not require any fitting. It is typical of most motherboards available today. This means that the memory used to store the display information is part of the main memory or RAM, which means in most cases is usually fairly low performance. For example, we could fit 4 GB of RAM to the system. The video card could be set to use 512 MB, only leaving around 3.5 GB available for the system. In addition, the process of the information that will be displayed will be handled by the main CPU. This will also cause an overall reduction in the computer's performance. So if we were designing a video card, which components should we use? Well, the first thing is we can create separate memory using SD-RAM. The main benefits of SD-RAM is it is faster than normal RAM. In our example, we have used 8 2 MB SD-RAM, giving a total of 16 MB. Next is we could free up the CPU by adding a CPU to the new video card, although they tend to be called GPU or Graphic Processing Unit. Because it will also be working in the same manner of a CPU, we shall have to dissipate the heat generated by it, so a heatsink will be added. As it will be plugged into the motherboard, it will need some sort of connector. In our example, it will be Agp. Of course, it will have to have an output that can be connected to a monitor, so a 15-pin VGA video output will be included. Now we add the rest of the circuitry. This is the 3DFX Video 3 video card. It should be noted that it is over 10 years old and no longer able to keep pace with the video demands that the present day applications require. In our next example, we have shown the MSI HD 7990 video adapter. Let's compare the specifications with the Voodoo 3 we saw earlier. The Voodoo had 16 MB of total memory. The HD 7990 has 6 GB, a lot more. The clock speed of the Voodoo was 166 MHz, which was considered at one time to be fast. The HD has a clock speed of 6000 MHz. The Voodoo has about 8.2 million transistors. This seems a lot, but when you compare it with the 7990, it is tiny. The 7990 has over 8.6 billion transistors. The Voodoo video adapter has one single output. The 7990 has 4 mini display ports and a DVI output, so it's able to drive more than one monitor at a time. It connects to a PCI Express slot found on the motherboard. The Voodoo plugged into the now defunct Agp port. Because of all the heat that the 7990 generates, it is equipped with 3 fans, while the old Voodoo display adapter had just a heatsink. It should be noted that at the time of writing, the 7990 is considered an excellent choice of a video adapter at just under £700, but video cards can exceed nearly £2,500. Just before we leave this subject, at this stage we should be aware of some of the motherboard slots that are used for video adapters. The original slot was the PCI. This can still be found on some motherboards, but it will only support very low performance video cards. There are 3 on this motherboard. Next is the Agp slot. As it's already mentioned, it has become almost obsolete, and you will only see these in very old systems. There is just one on this motherboard. The most recent video adapters use the PCI x 16 slot, and there are 3 on this motherboard. The output from the video adapter, as shown in the Voodoo adapter, is the VGA or Video Graphics Array. Almost all low-end video adapters and some of the high-end still support this. The DVI or Digital Visual Interface is found on high specification graphic adapters and produce very high video quality, but requires a compatible VDU. Finally, there is the HDMI, High Definition Multimedia Interface, which is the latest standard, producing very high definition video output.